What is up, YouTube? Mr. King coming at you live, not from the studio, but from the classroom today. Welcome. Thank you for watching King Academy. Let's get started. Today, you're going to learn why is it that when a 350-pound player collides with a 200-pound one, only one goes to the hospital. And I bet you can guess who. Okay? And what we're going to be talking about today is momentum. All right, momentum is mass times velocity. Or the shorthand for that is P equals m times v. And whoa, why is momentum p? That doesn't make sense. The reason is, I think, because m was already taken for mass, n was taken for newtons, o we haven't gone to yet, but it's for ohms, for resistance. And then, so they're like, oh, let's give momentum p. So p is momentum, and it equals mass times velocity. Okay? Very similar to the force equation, but we'll get into that later. So, they say something's momentum is like how much oof it has. We really think about momentum with collisions. So you can think of momentum as how much it'll hurt if you collide with it. Okay? So this guy is getting chased by a rock. He may be very fast, but that rock will kill him. Even if they're the same speed, because the rock has a lot more momentum, because it has a lot more mass. So the mass will make it have a lot more momentum, enough to kill the guy. Okay? And momentum is very similar to force. Momentum is mass times velocity, and force is mass times acceleration. Now try and remember the difference between velocity and acceleration. Hopefully remember acceleration is only changing velocity. So changing direction or speed, that's acceleration. Velocity can be constant speed though, okay? Velocity can work even if it's not changing speed. So force is only for changes, but we use momentum even for constant speed too. That's the nice thing about momentum. It can tell us how much momentum something has, how much oof it has if it's moving, even at the same speed. Force is only for changes in things. Okay, so that's a big difference. So we really save momentum for collisions. Okay, and speaking of collisions, I want you to know that objects with more momentum give more damage and take less damage. Okay, so the classic example is a car crash. If you have this semi-truck going the same speed as this car and they do a head-on-head collision, that semi-truck won't, it'll barely, if any, have a scratch on it. It'll completely knock the small car out of its path. And you'll see that like our earlier videos with trains. Trains don't even often stop when they hit something, even a car or truck. Trains just keep on going. That's how much momentum they have. So that's how momentum can play out in the real world. If something has a lot more momentum, it'll do a lot more damage to whatever it collides with, and it won't take as much damage itself. So that's how momentum looks. Okay? Next, I have a video for you. I want you to watch which player has more momentum. Okay, they're gonna do a replay in slow-mo. Here we go. So this guy just caught the ball, and then bam, he just flies. This guy is huge. The guy that hit him is huge. So he's normal running back height, and then this guy from college just completely destroys him. So he's famous. Usually football players aren't that tall, but he's 6'11" and 150 kilograms. Okay? And then he was going up against this guy who's 5'10", my height, 75 kilograms. Okay? I want you to figure out how much more momentum does the big guy have. The big guy's going a little slower. The big guy weighs 150 and he's going 2 meters per second. The running back is faster. He's going 3 meters per second, but he only weighs 75 kilograms. So right now, I want you to use the formula for momentum, which is mass times velocity. Pause the video now and figure out how much more momentum does the big guy have. Okay? Hopefully you noticed. You take the weight times the speed, and you get 300 for the big guy. And then you take the other guy's mass times his speed, and you get 225. So then to see how much more momentum, you subtract them. 300 minus 225 is 75 kilograms times meters per second. No special name for momentum units. You just keep the weight unit times the speed unit. Okay. Next one, I have a story for you. True story. There's a charity called Make-A-Wish Foundation. And this kid basically was a goalie and he was going to die from cancer. And this charity organization, they grant these kids wishes before they die. And it's usually involving celebrities. And his goal was for Lionel Messi, to shoot on him. So you may be wondering what happened, because Messi did fulfill his wish, and a lot of people may have thought Messi went easy on him. He didn't. Messi kicked the ball normal speed, and the kid tried to block it and actually broke his arm. It broke his arm. It broke his arm, okay? Messi kicked it so hard that it broke his arm. It blew his arm back so fast that it broke it, okay? And your job, you're going to figure out how fast did his arm move back, okay? Based on this. So to figure out how fast his arm moved backwards, we have to find the momentum of the ball first, okay? So Messi kicks a soccer ball that weighs 0.5 kilograms and moves at 50 meters per second. If the boy's arm weighs 5 kilograms, first step, before anything, we need to figure out how much momentum the ball has, okay? Pause the video now, try and figure out how much momentum does the ball have. Because momentum is conserved. So what that means is the momentum stays the same. Since the momentum of the ball hits the arm, all the momentum shifted into the kid's arm, okay? Since they collided and the ball stopped moving. So bam, it all went into the kid's arm. So you take the weight of the ball times the speed of the ball and you get 25. That's the momentum of the ball. Now we have to figure out how much momentum did the boy's arm have, and you set that equal to each other. So to figure out the speed that the kid's arm flew back in, we have to use this formula. It's called M1, V1, M2, V2. The ones and twos represent the numbers that you see first. So this is M1, it's the first mass you see, and this is V1, it's the first velocity you see. And then the boy's arm is M2. This is M2 because it's the weight of the kid's arm. But we don't know V2. We don't know the velocity of his arm. So what you do, or you could think of it as the momentum of the soccer ball equals the momentum of the kid's arm, or his mass times his velocity of his arm. Okay? So you set the momentum of the ball, P1, which is 25, equal to the mass of his arm, 5 times V2. Okay? This one's a little more complicated. There's more variables involved, but I have given you the formulas to help you. You know the momentum of the ball is P1. You know M2 is 5. Try and find V2 now. See how fast his arm moved backwards. Okay? If you did it right, because momentum is conserved, so you can set the momentum of the ball equal to his arm. You set it equal, so 25 is 5 kilograms times V. And to find V, we have to undo the multiplying by 5. We divide by 5, so 25 divided by 5, and we get 5 meters per second. And since it's velocity, it incorporates direction too. It's technically never -5 because the arm went backwards. So that is the answer. I would have taken either of them, 5 or -5, and that's how you do it. We set the momentum equal to the mass of the kid's arm times velocity, and we had to solve for V. So we ended up having to divide. And this all works because momentum is conserved. It just changes from one object to another. Yep, please write a summary in your notes. That was the last thing, everyone. Thank you so much for staying with me. I hope that helps you understand